Welcome friends to my channel Stat Info, where we have started a lecture series on sample survey. This is the 12th part of the series, and in this part we shall talk about probability proportional to size sampling. Previously we have discussed about cluster sampling, and in cluster sampling we have seen that there are three types of cluster sampling. First one is one stage sampling, then two stage sampling, then multi-stage sampling. Okay, and the two stage sampling is again divided into two parts. First one is simple cluster sampling and second one is probability proportional to size sampling. Okay, so still now we have discussed about cluster sampling and then one stage sampling, two stage sampling and simple cluster sampling. Okay, and now it's the time to discuss about probability proportional to size sampling. So this technique is first introduced by Hansen and Hurwitz. Okay, and since probability proportional to size sampling is one of the case of two-stage sampling, so obviously this probability sampling technique consists of two stage. Okay, and still now whatever random technique we have discussed, in all of the sampling technique, each of the unit within the population has the same probability of being selected in the sample, isn't it? But in case of probability proportional to size sampling, we will see some differences, okay, which we discussed in a very elaborate way, and I hope at the end of the video it is pretty much clear to you what is the process to take sample from the population by using the technique of probability proportional to size sampling. Okay, so this video is going to be a little bit long, so please be with us to understand the whole concept about probability proportional to size sampling. Okay, so in this technique I have already said you that there are two stage. First one is first stage unit and then second stage unit. Okay, so in the previous lectures of cluster sampling we have seen that the population consists of different clusters. Okay, and each of the cluster contains almost each and every characteristic of the population within it. Okay, and we draw some cluster from the population to our primary sampling unit, or you can say first stage unit. Okay, by using generally the simple random sampling without replacement. Okay, and after that we are not going to consider each and every individuals within the cluster for our sample. Okay, instead of that, what we do, we draw some of the individuals from each of the selected cluster by using the technique of simple random sampling without replacement for our secondary sampling unit. Okay, so this is the process which you have done in case of simple two-stage sampling. Okay, in case of simple cluster sampling or simple two-stage sampling, each of the cluster within the population has the same probability of being selected in the first stage unit, isn't it? But in case of probability proportional to size sampling, larger clusters have bigger probability of being selected in the first stage unit. Okay, so this is one of the difference. Okay, and in case of simple two-stage sampling, we generally apply the technique of simple random sampling without replacement to draw cluster from the population for our first stage unit. Okay, but in case of probability proportional to size sampling, we can apply both simple random sampling as well as systematic sampling to draw cluster from the population to our primary sampling unit. Okay, and after that, from primary sampling unit to secondary sampling unit, we use generally the technique of simple random sampling without replacement to draw units from this unit to that unit. Okay, in case of two-stage sampling, we decide about our sample size for each of the selected cluster based on the size of the cluster in the population, or you can say in the first stage unit. But in case of probability proportional to size sampling, here we are not going to take different sample size for different clusters. Okay, we use the same sample size for each of the selected cluster. That means the sample size for each of the selected cluster is same. Okay, so why do so? Since we have said that in case of first stage unit, all the clusters don't have the equal probability of being selected in the first stage unit, Okay, but the larger clusters have bigger probability of being included in the first stage unit. That's why we do this step. Okay, if we do so, then what will happen? In that case, the items within the larger cluster have smaller probability of being included in this secondary sampling unit. Okay, that means here the larger clusters have bigger probability to being included in this unit. But if we consider the same sample size for each of the selected cluster in case of secondary stage unit, in that case the units from the bigger cluster have smaller probability of being included in this secondary stage unit. Okay, so that each individual in the population has the same probability of being sampled. Okay, so all these things are pretty much clear to you when I discuss all these things with some example. Okay, so now to draw sample from the population by using the technique of PPS sampling, we have two methods. First one is cumulative total method and then second one is Lahiri's method. Okay, so we first discuss about cumulative total method and then we'll discuss about Lahiri's method also. Okay, so in this method what you do, first we have to list all the primary sampling units which contains in the population. Okay, and then we calculate the cumulative total of cluster population. Okay, and after that we have to decide about our number of cluster which is being sampled for our study. Okay, so after deciding this, we may use either simple random sampling or systematic sampling to draw cluster from the population by using this cumulative total method. Okay, so these are the main steps of cumulative total method. Okay, and here we are not going to very much bother about our sample size for our secondary sampling unit because it is already decided that we have to consider the same sample size for each of the selected cluster in case of secondary sampling unit. Okay, so these are some formulas which we use in the process to calculate various probabilities, like what is the probability of each cluster to be selected in our primary stage unit. Okay, so this is the formula, and the formula says as what? This is cluster population, that means size of the cluster divided by the size of the population. Okay, and this probability too says as what? This probability says as that what is the probability of each of the individuals to being sampled in our secondary stage unit. Okay, and this will be calculated by this formula, number of individuals to be selected from each of the sample clusters divided by cluster population. Okay, and since we know that the number of individuals to be selected from each of the sample cluster is same, that's why the numerator of this formula is going to be same for each of the selected cluster. Okay, while the cluster population is going to vary from cluster to cluster. Okay, so by using this two probability we can calculate the overall probability, and this is nothing but the multiplication of these two probability. Okay, so this overall probability says us that what is the overall chance of an individual to being selected in the sample in case of probability proportional to size sampling. Okay, and this overall weight says us that how much weight is given to each of the individual in the population to being selected in our sample. Okay, so we will see all these calculation in our example. Okay, so there will be no confusion after watching this. So let's start with an example. We have considered such an example where the population consists of 10 villages having different number of households. Okay, and just to make you understand all these things very simply, we try to give very small example to you. Okay, and one more thing I should mention that this example is not said by me. I have taken this example from another website. Okay, and I just use this example to make you understand all the process what I have used in probability proportional to size sampling. Okay, so you just see that there are 10 villages. Okay, and each of the villages contains different number of households. Okay, so the first village contains how many households? 35 households, and the second village contains how many households? 28 households, like that. Okay, so you can see that what is the total number of households in our example. Okay, so simply there is only 212 households in our example. Okay, so we have already said that in case of cumulative total method, first we list the primary sampling units. Okay, so these are the primary sampling units. Okay, and here we have calculated the cumulative total. Okay, now to draw cluster from the population to our primary sampling unit, we just consider this range. Okay, so this is the probability of selection of the cluster from the population to our primary sampling unit. Okay, and from this you can see that the clusters have larger size, has more probability of being included in our first stage unit. Okay, and how calculate this one? We just divide the cluster population by the total population. Okay, so cluster population is here 35 and our total population is 212. Okay, now how we can choose the cluster? By using the simple random sampling. Okay, for our first stage unit. So for this we have to consider the random number table, isn't it? And here, since we have seen that the population consists of 212 units, that's why we have to see the 3-digit random number, isn't it? So if we do so, if we get the random number 173, then which cluster will be selected? We can see from the range. Okay, so in which range the random number 173 contains, the cluster corresponding to that range will be selected for our first stage unit. Okay, now we'll see the number 173 contains in which range. Okay, so you can see that this range is what? 168 to 179. Okay, so obviously the number 173 contains in this range. Okay, that's why the selected cluster will be what? 8. Cluster number 8 will be selected for the study. Okay, that's why you have considered village 8 here. Okay, now suppose we get the random number 95. Then again we have to see the range. Okay, 95 contains in which range? So here you can see that 84 to 108. So obviously the random number contains in this range. Okay, that's why cluster 4 or village 4 will be selected for the study. Okay, and so on. Now you can see that there are 2 repetitions. Okay, so 140, it contains 139 to 157, and that's why you have to select the cluster 6. That means you have to select the village 6 for our study. Okay, now again we get 152, which again contains within the same range. Okay, that's why we have to again select the same cluster for the study. Okay, and next we get 32, which contains in the first cluster. Okay, that's why we take cluster 1 for the study. Okay, so here I have considered the 7 random number. Okay, just to make you understand that how we can choose the cluster from the population to our primary sampling unit by using both simple random sampling with replacement and simple random sampling without replacement. Okay, so suppose for example, out of this 10 cluster, we have already decided to take 6 cluster from the population for our primary sampling unit. Okay, so in that case, if we use simple random sampling with the replacement to draw cluster from the population to our primary sampling unit, then we will consider first 6 units for the first stage unit. And what are these? These are 8, 4, 10, 5, 6 and again 6. Okay, now if we want to select the cluster from the population by using the technique of simple random sampling without replacement, in that case what we will do? We consider 8, 4, 10, 5, 6 and then we will not consider these 6. Okay, we just drop it and after that we will consider this one. Okay, because in case of simple random sampling without replacement, we do not consider the repetition of the units. Okay, so this is the way how we can use the technique of simple random sampling to draw cluster from the population to our primary sampling unit in case of probability proportional to size sampling. Okay, and now in this table we will calculate all the probabilities or overall weight for each of the selected cluster. Okay, and from here you can also see that what is the probability of an individual to being included in our secondary stage unit, or how much weight is given to each of the individual to being selected in our secondary stage unit. Okay, so since in case of simple random sampling with replacement, we have seen that the cluster 8, 4, 10, 5, 6 and again 6 are selected out of the 10 cluster from the population for our primary sampling unit. Okay, so in case of village 8, we have seen that how many households are there? There are 12 households. Okay, in case of cluster 4, we have seen that there are 25 households and so on. So here I have given this probability in terms of percentage. Okay, so 6%. 6% means what? 6% means that the cluster 8 or village number 8 has 6% chance to being included in our first stage unit. Okay, whereas the cluster 4 has 12% chance to being included in our first stage unit. Okay, and cluster 10 has 7% chance to being included in our first stage unit, whereas the cluster 5 has 14% chance to being included in our first stage unit. Okay, so from here you can see that the bigger clusters have bigger probability to being included in our first stage unit. Okay, so here individuals per cluster. Now suppose for example, out of these 212 households, we want to collect data from only 30 households from different villages. Okay, so for this we'll consider the same number of individuals for each of the selected clusters. Okay, since this is one of the property of probability proportional to size sampling, because in case of probability proportional to size sampling, the sample size for each of the selected cluster in case of secondary stage unit will be same. Okay, that's why we have considered 5 for each of the selected cluster. Okay, now from this we can calculate the probability 2. Probability 2 says us what? It says that what is the chance of an individual to being selected in our secondary stage unit. Okay, and how we can calculate this one? We just divide the sample size for each of the cluster corresponding to their cluster population size. Okay, so we just divide 5 by 12. Okay, because the sample size for the cluster 8 is 5 and the population size for cluster 8 is 12. Okay, so we just divide 5 by 12 and we get what? 42%. Okay, since I have written all the probabilities in terms of percentage. Okay, so this is 42%. It means what? All the individuals in cluster 8 has 42% chance that they are being included in our secondary stage unit. Okay, whereas for cluster 4 it is 20%. That means each of the individual in cluster 4 has 20% chance that they are being included in the secondary stage unit. Okay, so here you can see that for cluster 8 the individuals have more probability of being included in the sample. Okay, whereas for cluster 4 they have lesser probability to being included in the sample. Why? Because in cluster 4 the size of the population is bigger than cluster 8. Okay, and we have already said that in case of primary sampling unit, bigger cluster size have bigger probability of being included in the first stage unit. Okay, and in case of secondary stage unit, individuals from bigger cluster has smaller probability to being included in the second stage unit. Okay, and these two probability compensate one another. Okay, so after calculating these two probability, we can calculate the overall weight. Okay, so here I am just considering the overall weight. I am not considering the overall probability. We can simply calculate it. It is nothing but the inverse of this. Okay, so when you calculate the overall weight for each of the selected cluster, you will see that the overall weight for each of the selected clusters are same. It means what? It means that each of the individual within the population has the same weight to being included in the sample. Okay, that means here we are not considering like that some of the individuals have more weightage to being included in our sample and some of the individuals have less amount of weightage to being included in our sample. Okay, so from this you can say that all the individuals have equal amount of weightage to being included in our sample. So this is the way to calculate all these things, and this is the physical meaning of all these measures. Okay, and same thing we can calculate for our sampling units which are selected in case of simple random sampling without replacement. Okay, and here also you can see that the overall weight for each of the selected clusters are same. Okay, that means whatever sampling technique we are using to draw the cluster for our primary sampling unit, in all the cases the weights for individuals are not going to change. Okay, the weights for the individuals to being selected in the sample are same for each of the random technique, which will be more clear when we will discuss about the systematic sampling also. Okay, next we will discuss about how we can use the systematic sampling technique to draw the cluster from the population for our first stage unit. Okay, so here we will consider both the cases, linear systematic sampling as well as circular systematic sampling. Okay, so that nothing will skip in the topic. Okay, so we know that in case of linear systematic sampling, the sampling interval should be a whole number. Okay, here we will draw 4 cluster out of the 10 cluster just to make the sampling interval a whole number. Okay, and nothing else. So how we can calculate the sampling interval? You have to divide the population by the number of sampled clusters. Okay, so if we divide 212 by 4, we will get 53, which is a whole number. Okay, so we can go for linear systematic sampling. Now we have to choose a number between 1 and 53, both are inclusive. Okay, so after choosing the number between 1 and 53, we just add our sampling interval to get our desired sample size. Okay, so suppose for example we get the random number 20. Okay, now we'll see that the random number 20 lie within which range. Okay, so from this you can see that the random number 20 lies in this range. Okay, 1 to 35. So obviously the cluster 1 is going to be selected for our first stage unit. Okay, and after that, to get the second unit, we just add the sampling interval to this random start. Okay, so 20 plus 53, which is equal to what? 73. And 73 lies in which range? 73 lies in this range, 64 to 83. So from this we can see that the cluster 3 is selected for our first stage unit. Okay, and again we use the same process, 73 plus 53, and we will get 126, which lies within this range, and correspondingly we get cluster 5, which will be included in our first stage unit. Okay, and after that we will get 179, which lies in this range, so that we will get the cluster 8 in our first stage unit. Okay, and after this we are not going to continue this process because we have already get our desired sample size, that means 4 cluster now. Okay, so we'll stop here. Now what you do in case of circular systematic sampling? So in case of circular systematic sampling, the sampling interval is not a whole number, we get a fractional number. Okay, so just to get a fraction we consider here n is equal to 6. Okay, so after dividing 212 by 6 will get 35.33, which is a fraction number. Okay, and here we consider the just bigger integer from this fraction. Okay, which is equal to 36. Okay, so our sampling interval in this case will be equal to 36. Okay, so here we choose a random number between 1 to 212, both are inclusive. Okay, so this is the condition to take units by using the circular systematic sampling, which I have already discussed in very detailed way in our lecture systematic sampling. Okay, so I am not going to repeat this one. Okay, now suppose for example we get the random start 40. Okay, so we'll see that the random start lies in which range. Okay, so from here we can see that 36 to 63, that means the random number 40 is lying between this range 36 to 63. Okay, it means what? It means that cluster 2 is being selected for our first stage unit. Okay, so after getting this, we do what? We just add our sampling interval to 40 to get our next unit. Okay, so after adding 36 to 40, we get 76, which lies in this range 64 to 83. That means what? We are getting cluster 3 as one of the unit in our first stage unit. Okay, and again we add 36 to 76 to get our next unit. Okay, and we will get 112, which lies in this range 109 to 138. Okay, so obviously we'll choose this cluster for our first stage unit, and again we will continue this process. Okay, so here you can see that we get 186 and correspondingly cluster 9 is selected. Okay, this will be 184. Okay, so this is just a printing mistake. So if we add 36 to 184, we'll get what? We'll get 220, isn't it? So from here you can see that 220 is not within our range. Okay, we have up to 212. So what we'll do? We just subtract our total population from this random number to get a number. Okay, and whatever number we get after subtracting these two, we consider this for our study. Okay, so if we subtract 212 from 280, we get 8. Okay, and this 8 falls in which range? This 8 falls in this range. Okay, 1 to 35. That's why cluster 1 is being selected for our first stage unit. So this is the way to draw cluster from the population for our first stage unit by using the circular systematic sampling method. Okay, so here I just calculate all the probabilities and overall weight for each of the selected cluster which you get in linear systematic sampling as well as circular systematic sampling. Okay, and I have discussed about all these measures in case of simple random sampling also. That's why I think this did not to be discussed again. Okay, you can simply see from the table that here also the overall weight for each of the selected cluster are same. That means whatever weight are assigned to the individuals, they are going to be same for each of the individuals. Either we use simple random sampling technique or we use systematic sampling technique to draw cluster from the population to our first stage unit. Okay, now we again take the cluster from the population by using Lahiri's method also. Okay, so in case of Lahiri's method, we are not going to calculate the cumulative total. Okay, here we will just see that what is the maximum cluster population. Okay, and what is the number of cluster in our population. Okay, and these two numbers will be in use to draw cluster from the population to our first stage unit. Okay, so just see that this M is what? This M is maximum cluster size. Okay, and I is going from 1 to n. N is what? N is the total number of cluster present in the population. Okay, so in this case we have to select a pair of random number. Okay, and these are named as I and J. Okay, I is what? I is for the number of cluster. Okay, and I should vary from 1 to capital N. Okay, and J is what? J is the cluster size. Okay, so obviously it will vary from 1 to capital M. Okay, now if J less than or is equal to Xi, then ith unit is selected, otherwise rejected. Okay, and if we reject, then we have to continue this process for another pair of random number. Okay, and we will continue this process until we get the desired number of sampled cluster. Okay, so in our example, whatever example we have discussed till now, in that case we can see that the maximum cluster size is 35. That's why capital M will be equal to 35. Okay, now we have to select a pair of random number I comma j such that 1 less than is equal to I less than or equal to 10, because we have 10 cluster in our population. Okay, and J is varying from 1 to 35. Okay, sorry, this is not is equal to 14, this will be 35. Okay, now suppose we want 4 sample cluster. That means we want to draw 4 clusters out of the 10 clusters. Okay, by using the technique of Lahiri's method. So what we'll do, so in the first column I have written first random number which varies from 1 to 10. Okay, and in the second column I have written second random numbers which varies from 1 to 35. Okay, now this is the observation and then selected cluster. So you can see that we get first random number 1. Okay, and then we get 32. That means 1 and 32 first pair we get. Okay, so in that case you can see that the value of J is equal to 32. Okay, and this is less than x1. x1 is what? The original number for cluster 1. Okay, since cluster 1 is selected here, that's why we have to consider cluster 1. Okay, so we have to see that what is the original number of household in case of cluster 1. Okay, if the random number is less than the original size, then that cluster will be selected for our study. Okay, so we can see that the size of the cluster for cluster 1 is equal to 35. Okay, and this J is less than 35. That's why this cluster 1 is being selected for our study. Okay, so now we go to the next row. So here you can see that 2 is selected, and corresponding to this we get 52. Okay, so now we have to see that what is the size for our second cluster. Okay, if the size for our second cluster is greater than this one, then we'll select this cluster also for our study. Okay, but since we know that the size of the population for our second cluster is equal to 28, which is less than this 52, that's why we are not going to take this cluster in our first stage unit, because the condition says us that we have to select the cluster in such a way that where the value of I lies between 1 to 10, and whatever cluster we get corresponding to that cluster, if we get a random number in such a way that that random number is not greater than the original size of the cluster, then we can accept that cluster for our first stage unit. Okay, so since the value 28 is less than this random number, that's why cluster 2 is not going to be selected. Okay, it is rejected. So here you can see that in place of 5 you get 3, and corresponding to that we get 17, which is less than 20, and 20 is what? 20 is the original cluster size for cluster 3. Okay, and since this 17 is less than 20, that's why third village is selected for our study. And similarly x5 is equal to 30, and here we get 26. That means this random number is less than the original cluster size for cluster 5. Okay, that's why cluster 5 is also selected, since we get the pair 5 and 26 together. Okay, now we'll see that we get 6 and 68. Okay, and when you get 6, we have to see that what is the cluster size for this cluster. Okay, so we can see that the cluster size for cluster 6 is equal to 19. That's why it is rejected. Okay, so we continue this process up to the desired sampled cluster. Okay, as soon as we get the desired sample cluster, we'll stop that process. Okay, and then after getting the cluster from the population to our first stage unit by using the Lahiri's method, all the calculation for secondary stage unit are not going to change. Okay, because in case of secondary stage unit we have to consider the same sample size for each of the selected clusters. Okay, so I hope now we can easily calculate all these measures for this particular method also. Okay, so this video is little bit longer in comparison to the previous one. Okay, because I don't have any choice to make you understand all the methods which are used in probability proportional to size sampling. Okay, and now I hope that all the techniques are very clear to you, and if it is so, then please like, share and subscribe my channel, and please watch this lecture till the end, okay, so that you get the full concept about probability proportional to size sampling. Okay, and after this video we are going to upload the lecture on multi-stage sampling, multi-phase sampling, and then sequential sampling, and then snowball sampling. Okay, and after that the lecture series on sample survey will be finished. Okay, and then we can start another topic. Okay, so please like, share and subscribe my channel and watch my channel so that I get motivation to make more videos on other topics also. Okay, so thank you so much for watching my video. Thank you.